Alrighty guys, what is up? Welcome back to The Farmer Was Replaced with Lone Debater 7, and today we're basically picking off like where we left off last time. So I fixed our function call here. So it's been running for a little bit. We're currently trying to build 510 of each of the resources, so we're running through our wood right now, then we'll swap to carrots. But while this guy's running in the background, I do want to go ahead and dive in and start building a program to do trees, because trees will give us a lot more wood than bushes. So the thing about trees, you basically can't have them placed next to any other trees or else it increases the growth time. So we kind of had built out this little code window at the end of the episode yesterday. So let's go ahead and set up tree B and kind of build what we want here. So if can harvest, you're going to harvest. So easy peasy. And this needs to be inside of a while loop. So tree B, so while our yes, we need to set up the variables. That's correct. Okay, so I need to go T, or well, I can use the same thing. So W equals num items, items wood. And what we're going to do here is while our RWD is greater than and equal to RWD, we're going to run this program. Okay, so now we just need to indent these one more time, baller, and that's that. So if you can harvest, harvest. Now what we need to do is basically we need to program a little bit of logic to say, okay, if you are in one set of rows, you're going to go tree, empty, tree. And then if you're in the opposite set of rows, you're going to go empty, tree, empty, tree. So you're going to checkerboard pattern this. The easiest way to do this is by checking your drone's position and then running a modulo instruction. And basically, if a number of row or your position is even on the X and odd on the Y, plant a tree. And if it's odd on the Y and even on the X, plant a tree. That's basically what we're going to do here. So let me just show you what this looks like. So if get pause Y mod, which is the percent side, 2. So basically what this does, modulo, if you're new to that, it's going to take whatever this number is. So say this number is 4, right? It's going to try to divide it by whatever number this is. So 4 divided by 2. And if there's no remainder, it will equal 0. If there is a remainder, it will equal 1. So this will either return 1 or a 0 or a 1 based off of whether there's a remainder when dividing this number by 2. So if we're on an even Y position, then this is yes. If we're on an odd Y position, this is no. So if get position Y mod 2 equals 0 and yeah, we need to add in some extra stuff here. And we maybe don't need to add this in, but I do it anyway because why not? And then we need to check our X position as well. And I'm going to do these opposite from each other. It honestly does not matter. You can do it however you wish. So do this, then you're going to plant entities.tree. Thank you. Good job. And then I do need you to move after doing this. Elif, your get, and actually, I don't know why I'm typing all that. I can literally copy and paste this whole string. We're changing 2 numbers inside of it. So this is going to go to 1. This is going to go to 0. And that's going to be equal 0. That's going to be does not equal 1. Then you're going to plant entities.tree. And then you're going to run mv.b mv. Oops, sorry, kind of bumped my mic there. Cool. And then I do need to throw in the import instruction. mv, we need to update our WD variable at the end of this. Cool. And now we have trees. So kind of what I want to do here is stop our main program execution. We're going to buy what we can buy here. So getting lists is honestly kind of good. We'll get lists. We'll talk about that in a second. Scaling trees, also pretty good. Scaling wheat, also pretty good. We'll save up and try to get pumpkins next so we can look at programming that. What is this? One too many? Is that it? You content now? Okay, happy days. So all I need to do here is import tree instead of bushes. And honestly, I can still import bushes. We just won't ever use it again, most likely. And it's going to be trees dot tree, just like that. Okay. Now, when we need wood, it's going to be stacking trees instead of bushes, and we will get a lot more wood out of that. I am just going to close some of these guys that we went over last time to clean up my screen a little for you. The thing we could do on carrots here. I mean, it wouldn't be the worst to honestly plant the bushes. So, like, if I import these other ones in here. And I'm just doing this mainly so I can run the trees when I'm doing my carrot farm as well, because it is worth doing that. So, okay, that's checking for carrots. Else if num items, hay. This is annoying because I'm gonna need. Or well, I guess all I have to do is pass in the RC into the plant. So instead of this, we're gonna run grassy strawman RC. Because if I do that, that'll pass. Yeah, that should be fine. And then on this one, it's going to be trees dot tree RC. And that should work just fine. And we basically just made this run the functions as opposed to having them typed out inside of the program, so it's a little bit better. But we also optimized it by running trees instead of bushes. So let's go ahead and I can't afford anything. Let's go ahead and start up our main. We should plant trees right out the gate. Why did that not? What's going on here? Yeah, I have this backwards, so. I think it's like this. There we go. Sorry about that. So it is equal, 0, equal, 1, and then not and not to get the trees to plant, right? That's fine. So we're rocking carrots. Amazing. Must be going to 400 carrots, I guess. Or it's 510 carrots is probably what this is. I did this backwards. So what I want is, if it's even and your x is odd, plant a tree. Okay? If your y is odd and your x is even, plant a tree. There we go. Sorry about that. It's a pretty easy thing. It's only like 4 lines of code, but like getting the operators right there is what makes it a little bit complicated. No worries. We got it figured out, I'm pretty sure. We have to wait until it like harvests all these trees and tries to plant trees again. But that's fine. So we do have some more. We can get pumpkins right out if we want. Could do sunflower. I kind of like pumpkins better than sunflower, so we'll grab pumpkins, and we'll kind of look at building that out today, I guess. We got time. So pumpkins, they grow on soil like carrots. They cost carrots to plant, right? So that's what they do. Ooh, yuck. Why is that not doing its thing? Oh, because this is a... I forgot the modulo. That's why. Gosh, stupid. This also needs a modulo too. That makes sense why it was not working. So if that mod 2 equals 1, it's odd. This mod 2 equals 0. There we go. That should fix our tree so it actually plants the whole field. There we go. There we go. Okay, pumpkins. So basically the thing about pumpkins, what is different about them is they have a chance to fail their growth cycle and turn into a dead pumpkin instead of a real pumpkin. You also get more pumpkins by forming a mega pumpkin, which is basically if you have a perfect square of pumpkin tiles that are all fully grown, they'll form a larger pumpkin, which yields more. So the idea with pumpkins is you want every single tile in your farm to be a fully grown, healthy pumpkin and have no dead pumpkins so you can harvest the maximum size mega pumpkin possible given your field size. So, not difficult. It does cost carrots, and the failure rate is kind of semi-random. So you want to make sure you have a buffer of carrots relative or like based upon your field size when you're going in to execute your pumpkin script. So what we're going to do here, we are going to utilize our carrot call for pumpkins just so we can maintain a level of pumpkin. Or like we can ensure that we have enough carrots to finish the call. So we'll call it pumps and death, pumpy, and our RP for request of pumpkin is all we should need to push into there. So we want to go P equals num items dot pumpkins, right? Easy enough. Then we're going to define a while loop, which is going to look at RP being greater than equal to P. I am going to want our water call, so we will call in water. We're also going to run the till soil. So, all right, let's do this. We need to import some stuff. So we need wet. We need to import MV. We need to import grassy. We need to import trees. And we need to import carrots. Because we might need to use all of them, right? So let's define this. If we can harvest, then you're going to harvest. Easy peasy. Done. No, JK, we're not actually done. So we need to till this ground if it's not. So if get ground type does not equal soil, which is grounds.soil, then you're going to till. Otherwise, don't worry about it. Cool. Now, what we need to do is check our hay and our wood, or well, yeah, it's basically this carrot function, but a little different. So let's do this. RP. And I think we want to do it as RP times 2. Like if we have double the field size worth of... Well, honestly, I don't need it like that. Let me just type it base. So if our num items.pumpkin. No, that's not what I want. If our num items.carrots, they have to be greater than or equal to the RP, the requested pumpkins. Then we want to run the pumpkin command, which is basically going to be get entity stat or check entity, get entity status. I forget what the function is called, to see is there a pumpkin there? Is it grown? If it's not a grown pumpkin, you're going to plant a pumpkin. So let's do this. So if get entity type does not equal pumpkin, scroll down there, does not equal pumpkin, then what I want you to do is harvest and plant entities.pumpkin and run wet dot water. So okay, we check if we have enough carrots to do the whole field, and really we'll do two times the number of carrots for the whole field, just to be safe. That should be sufficient to plant the whole thing. Or well, no, this will auto check. It's fine. We can just do it like this. So, all right, if we check the tile and it's not a pumpkin, we're going to harvest that tile and plant a pumpkin. We're already harvesting up there. I don't need to do this. We check to see if it's tilled ground and till it. That's done. So plant pumpkin and then water pumpkin. Elif our no, that's it. So if it's not a pumpkin, plant a pumpkin, and then you're going to run move, base move, and move through the farm and run the next piece. Okay, and actually I don't want to move in this piece. It's going to be outside. So now, elif num items.carrot is less than RP. You're going to instead run carrots dot carroty up to RP. So the requested number of pumpkins. Else if carrots, carroty, boom. Then what you're going to do is mv.bmv. So you're going to move, and then you're going to repopulate our variable to check and see how many pumpkins we have. And that should be our pumpkin set up, assuming I put in this colon. I think that will do what we want. Or well, no. I need to adjust this because right now what this will do is when it comes across a live pumpkin, it'll harvest it. So if can harvest and get entity type does not equal pumpkin, then you can harvest. Okay, so this will clear everything that's not pumpkins out of the field. This will till if it's not soil. This will plant pumpkins if there's enough carrots to plant pumpkins. And then nested inside that is if we've got a pumpkin, if it's not a pumpkin entity on the tile, plant a pumpkin, water it. Else if the get entity type equals entities.dead pumpkin, I want you to harvest it. Then I want you to plant entities.pumpkin. I don't know if I actually need this extra little bit here, but I might. I don't know how the dead pumpkins work, if I'm being honest. So we'll try something like that. Basically, what I need to do, if I want to wait until we have the max size pumpkin, I more or less need a check based off of world size that I have that many pumpkins. Um, hmm, hmm, hmm. How do I do that? I guess what I could do is while it's moving, so like before you move, check if the entity is a pumpkin. If so, increment this variable by 1. Once that variable count equals the world size, you can harvest the pumpkin. But you have to set it to 0 up at the top every time. So, okay. Total pumpkin is 0, right? So every time the loop runs, it sets this to 0. What we're going to do is run a get entity type. And if that equals a pumpkin. So let me just break this down. So if we've got a pumpkin entity, then what we're going to do is we're going to take total pumpkin plus equals 1. Then before we move, so the issue is it has to store it through the entire move across the field. Okay, so I need another one that is moves. And this one I honestly don't want set there. I want it set up here, and then it's going to auto update it. And I think I want to do the same with the total pumpkins. Because basically what we're going to do here is we're going to count how many times we've moved. Once our total number of moves is equal to the field size. No, that doesn't quite work because... Does that work? It doesn't because of the way our move is set up. Basically, what's happening here, we have 2 moves in this. So let me see something real quick. If I take this north out, will it still work? No, it won't. It might if I do this. And I guess I actually no. This will be fine because I'm not tracking it off of the actual calls of this move. I'm tracking it off of the calls of the function, which is going to be defined based off of the number of times we're moving through each tile. So that should be fine. Okay, we're good. We're good. So once we move, we need to what did I call that? Moves. Okay. Moves plus equals 1. Then go back through the loop. Need to remove that. Or no, I actually didn't want to remove that. I do want to check if our get entity type is pumpkin entity, total pumpkins plus equals 1. Ooh, what happened here? Oh, did it just... Oh, I didn't have enough water. Interesting. I don't know how that worked, but strange. Okay, fine, fair enough. That's what I'm talking about. Like, I mentioned it in a couple episodes ago. The water sometimes does weird stuff. But okay, pumpkins. So, total pumpkins goes up by 1. Cool. If our moves equals get world size times itself, then what I'd like to do for our total pumpkins, I should just make a variable for this, so I will. Double world size, cool. Then this will be DWS. Okay. Moves can go outside because I do need to set this equal to 0. Okay, so what does this do? Let's explain. Um, let's explain because I was kind of in the zone there programming for a second. So what do you need? A colon. Fair enough. Okay, so what we added down here is basically we're running a counter that counts how many times we move, which is right here. So we move, we increment this counter. We check before moving if we have an entity pumpkin, and if the total pumpkin is, if we do have a pumpkin, we go 1 to our total number of pumpkins. What this is doing is, if our moves is equal to double the world size, so we moved the world size 25 times, then you're going to check, is our total number of pumpkins equal to double world size? Do we have 25 pumpkins that we have scanned while moving 25 tiles? If so, then you can harvest and we'll get the mega pumpkin. If we don't have pumpkins equal, like if it's not equal to our double world size, make that a 0, make our move 0. After, like every time our moves equals double world size, you make our moves equal to 0. And then you go back through the loop. And you keep doing that until you get the mega pumpkin, more or less. So let's see if this works. We do need to adjust our main real quick just to account for our pumpkin. So AMT pumpkin equals 10. Actual pumpkin equals num items dot pumpkin. Then I need to add this guy to there, and this guy. Oh, I need to add it in on these conditions too. I know I can spell sometimes. It's fine. There we go. Okay, that should be good. Let's see if it works. Oh, it would maybe work if I actually like put in the rest of the stuff. Lol. Import pumps. Then we're gonna go in here. Okay. So that should do that. And we should see it start with pumpkins, I believe. Oh, it also might help if I put in the checks for our pumpkins here on both of the while loops. Otherwise, it will not actually plant them. Because it'll see that the 3 conditions are fine. But really, it should be checking 4. Okay, let's see if it starts planting pumpkins. Please plant the pumpkins. Oh, lol. All this is outside of the while loop. That's hilarious. Okay, there we go. Try it again. There we go. We get some pumpkins. Phenomenal. Plant them up, my droney drone. So you can see these guys are growing because they're in a square of all live, fully grown pumpkins. Ooh. Value wasn't assigned to it. What do you mean? But it is defined up here. That's really strange. I mean, I guess the other way I could do this is it's because this must not have triggered, I guess. Let's just try the global modifier. It seemed to think that's what was necessary. Weird. Why does it not see that variable? I guess what I can do is just set it equal to itself. Did I just misspell it? Put an S on it. Silly me. Syntax error. Okay, yes. The code was right. It was a syntax error. I'm okay with that. Interesting. How did it count that? Okay. So why did you stop? Where is it locked at? Like that's super. Alrighty, guys. So I figured out what was going on here. Basically, the issue was my while loop up at the top that would increment my amounts was not being triggered when we exited out of this while loop that actually runs the function calls. So what I needed to do in order to fix it is throw in this if statement inside of this while loop. And basically, what that changes is if while executing this loop, it detects that, hey, our amount for all four of our items is less than the actual amount we have on hand, then add another 100. So I needed to add in this little bit of code to capture if our actual on hand exceeded the requested amount while running the script more or less. And then I still need this while loop up at the top because if I enter in and I have more than 10 on hand of anything, this will basically bump it up to 100 and 110. Like it goes by 100 every time until one of the values is no longer greater than, like our actual on hand is no longer greater than our amount on hand. So we'll see here, this is the pumpkin. When it harvests, should do it soon. Boom. Ugh. Why? Why? I don't understand why it's doing that. That's like super, super strange. It's like it'll only go up to one pumpkin. So let's do this. I'm going to throw this boy right there. I'll do carrots first for a minute here. But I want to watch what happens when it runs our pumpkin. Because it's almost like it's not finishing the rest of the while loop, which it totally should. So I'm not exactly sure. Like maybe it's just a bug or something. But like I'm pretty sure the program works. Like I had it in a way where it wasn't doing the wheat, the wood, and the carrots there for a little bit. Like it wouldn't auto increment, but now it will. So okay, it finished that. Go in, it checks, increment, 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 then go. Yeah, we have to plant some grass here, so that's fine. Wait until it goes over to pumpkins, then we can stop it at the breakpoint. Okay, so finish carrots goes in. Increment. Now it's going to run grass. No, it's going to run carrots. Okay, so finished our carrots. So it should come down and run our pumpkins. Runs our pumpkins. Okay, it's going to scan. Harvest. So it's right here, right? Checks this code. It increments, 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 increments. Now it's going to run carrots. Okay. So strange. I wonder if it's because we maybe run into a situation where this doesn't, like, the 100 that we're adding isn't sufficient. You know what I mean? It could be something like that. Well, I think we're going to wrap it up here for today. It's been a longer one. If you enjoyed it, be sure to like the video, drop a comment if you have questions or any suggestions, that kind of thing. Until next time, this has been Lone Debater 7, and we will see ya.